Took me a while to figure out what it is, and then when I did, it says, why did they do it that way? If you take the Beer's law equation, in fact, I think I have that over here. I don't want to go that far just yet. If you take the Beer's law equation, it says that is equal to ABC, where C, well, excuse me, that's not correct. Absorption equals ABC, which is equal to AB times this concentration. And to solve for that, simply divide through by AB. And that's all well and good if you knew what AB was. Well, in this scientific paper, they actually go through a whole bunch of algebra, and the paper suggests that you should have your PChem students derive the equation on their own. Problem is, do any of you know what the method of reversion of series is?
No idea.
No idea. So you probably don't know what method to use to solve this. You can look it up. I had to look it up. I remembered going through it in one of those math courses many years ago, but I couldn't pull it from memory, so I looked it up. And basically, they give you that equation for A over AB, which is exactly what we need. So if we simply put that in there, dropping the higher order terms, because when you have the higher order terms, CF and CS are on the order of 10 to the minus 3 or 4. So when you take that and multiply them together, 10 to the minus 3, 10 to the minus 3, and 10 to the minus 6, and you square that, you get 10 to the minus 12. The next term is 10 to the minus 18. So these higher order terms get small very quickly, and we can simply neglect the higher order terms. So we have, this is equal to, according to this, CF, CS, divided by CF plus CS plus 1 over K observed. But that's not the equation that they give you right here, where they show you to calculate that in the little table. They have K observed CF CS plus over 1 plus CF plus CS times K observed. It's a different equation. That puzzled me a little bit until I recognized, and you should have figured this out too by now if you're really math savvy. Multiply through by 1 in the form of K observed over K observed, you get that. That's equal to CF CS times K observed. And here we get K observed times CF plus CS plus, and when you multiply that through, you simply get 1. That's not arranged in quite the same way, but that's the same equation they have there. But it occurs to me that why bother doing that? What's in parentheses there is a perfectly good way to calculate that factor. Why take the extra step, which means if you program this into Excel, you'd have more things to program. Why don't you just leave it with the simpler calculation? So that's what we're going to do. An awful lot of dilution calculations. That's the most complex of the others. You'll see as I go along how I set this up. I do want to remind you of one thing. We need to calculate the ionic strength, which is 1/2 times the sum over all the ions present of the charge on the ion squared times its molarity. We're using molarity, and I think I am going to put in what the paper uses and multiply that by the solution's density, which allows you to get a more accurate correction from molarity to molality, from molality to molarity.
Is that molarity squared?
No.
Okay.
Charge is squared to get rid of the negative signs. Well, you don't want negative charge to subtract from positive charge, because in reality, the total negative has to equal the total positive, which would say that the charges cancel out, the ionic strength is zero.
Your computer just shut off.
This is set for a, I think that was 15-minute time. Now we're back. So that's the way we're going to do that, and what we use this for is in the calculation of gamma, which is logarithm base 10 of gamma for a given ion is equal to minus 0.509 times the charge on that ion squared times this big thing in brackets .30, where we put the ionic strength into this term, and assuming I'm already dividing out the concentration units, so I'm not writing it as I over M0, where M0 is the standard molarity to divide it out. That's where we're going to go. I'm going to do this in pieces. I'm going to calculate that by itself, because this goes into the calculation of gamma for all three ions. So rather than program it 3 times, I'm going to program it once. So, pull up my spreadsheet. See how long my battery lasts. Where's the spreadsheet over here? There's the spreadsheet that I'm working on. Notice the constants over there in the left-hand column. Do those look like the concentrations of your solutions?
Nope.
No.
No, they're not. Not even close. Those are half again bigger. So, the way this data set was generated, by the way, was to make up a value for the equilibrium constant and work backwards. I dry lab the experiment to generate a set of fictitious data so I can show students the calculations without showing them any of the answers. This was for freshman chemistry, which is the simplistic way to do it. I am not sure if I'm going to get a reasonable value for equilibrium constants the way we're doing it. I may not, but it will allow me to show you exactly how to do the calculations. And this is what we've got to do. We've got to calculate, put in the milliliters here, we've got to calculate those concentrations, and I'm wondering why I didn't put CF there. So CF is the diluted iron concentration in the test tubes you put together. How did you make those?
5 milliliters of
5 milliliters of the stock iron solution. So 5, Excel doesn't deal with significant figures, so I'm not going to put in the 5.00 that are technically there, times the concentration of the iron stock solution, whoops, just one of those cells, and I have to put that in absolute address. So I'm going to put a dollar sign in front of the 8. The column A is not going to change anyway, so I'm going to put it in front of the 8. And let's see, what do I need to divide by? What's the total volume? 10 milliliters. So there's my iron solution. You might well not even bother taking pictures of this. Well, if you're recording the steps along the way. Well, the way I'm doing it requires that the data be in exactly the same place in the spreadsheet that mine is. When you construct a spreadsheet, you better do it with everything in exactly the same squares, or it's not, the functions won't program the same way. You need to figure it out for yourself. That can be pulled down and click and drag, but I can do the same thing here and do this nicely. I'm like, well, should I even bother doing it do that cell? I can. The answer is gonna be 0, because I have 0 milliliters of thiocyanate times the concentration of thiocyanate in absolute address. At least the row number has to be absolute, and the final volume is 10 for this one too.